Let's solve another problem from the 11th Philippine Mathematical Olympiad. The length of each side of the squares ABCD and DEFG, both labeled in counterclockwise direction, is 5 units. If AG is 8 units, how many units is BF? Okay, so I have already prepared a figure for this problem, but originally the problem does not provide a figure. Okay, so what I'll do first is extend sides AB and GF to form triangles. Okay, so I'll start with side AB and have this extension. So this is supposed to be a straight line containing AB. Similarly, I also have this extension, and let's call the intersection of these two lines T. Now, observe that the figure is actually symmetric or symmetrical along the line TD. Okay, so let's capitalize on the symmetry we've found. Let's construct line TD. Okay, so line TD is perpendicular to AG and BF. Okay, and so AG and BF are parallel. So let's take note of that because uh, this will be this will be helpful later on. Now, line TD also divides the figure into two identical parts. So if this intersection point of TD and AG is P, then AP must be 4 units and PG must also be 4 units. Also, notice that triangle TAG is similar to triangle TBF. Okay, so what are the reasons? Um, because AG and BF are parallel with TB and TF being transversals, then this angle must be congruent to this angle. Similarly, this angle right here must also be congruent to this angle right here. And of course, the third pair of angles must also be congruent. Angles ATG and BTF. Okay? So, we know that triangle TAG is similar to triangle TBF. Now, recall that when two triangles are similar, then their corresponding sides are in equal proportion. Now, with this, we can say that TG divided by TF, take note, I'm taking the corresponding sides. So, TG divided by TF equals AG divided by BF. Okay, since we want the length of BF or the value of BF, let's solve BF in terms of the other sides. So, if we do that, this equation is equivalent to BF equals AG over TG times TF. Okay, now I'll break down TF into the sum of TG and GF. Take note, from this side, okay, we can say that TF is equal to TG plus GF. Okay, so uh, let's take note that TG, I mean TF equals TG plus GF. So if we replace TF with GF plus TG plus GF in this equation will become BF equals AG divided by TG times TG plus GF. Now, if we simplify further, we get BF equals AG plus AG divided by TG times GF. Okay, take note that some of the values for these sides, for some of these sides are given. Now AG is actually equal to 8 and GF is equal to 5. But TG is unknown. So let's replace AG by 8 or with 8 and GF with 5. So we have BF equals 8 plus 8 over TG times 5. Okay, so if we simplify this further, we get BF equals 8 plus 40 over TG. Okay, now, if only we know the value of TG, then the problem is already solved. So how can we find TG? Let's go back to the figure and find some more similar triangles. Okay, let us focus on triangle TGD. Okay, TGD. Take note that this is a straight line. Okay, and so if this is 90 degrees, because this is a square, this angle right here must also be 90 degrees. And so triangle TGD is a right triangle. Now suppose that this angle right here is alpha and this angle right here is beta. So again, the angles of TGD are alpha, beta, and a right angle right here. Okay. Now recall also that TD is perpendicular to AG, okay, by symmetry. So this is a right triangle, as I have said before, okay. Now if this is a right triangle, then if this is a right angle, then triangle TPG and GPD are also right. Okay. Now let's focus on triangle TPG. If one of its angles is alpha, okay, and alpha is also an angle of triangle TGD, okay, and the other angle is 90, take note TGD has also a right angle, then it follows that the third pair of angles for these two triangles must also be the same. Okay, so this must also be beta. Okay, again, the first angle for triangle TPG is alpha. Triangle TGD has also an angle of alpha. Okay, both of them also have a right angle. So their third angles must also be the same. So if the third angle of triangle TGD is beta, then the third angle of triangle TPG must also be beta. Now the same reasoning can be applied to triangle GPD. So if this is beta right here, this must also be alpha. Now, what can we draw from this? The three triangles are actually similar to one another. Okay, now I will use the triangles TPG and GPD to form an equation, because take note that when triangles are similar, again, their corresponding sides are in equal proportion. Now what we will do first before we create an equation is identify the corresponding sides. Okay, so for triangles TPG and GPD, the corresponding sides that we are going to use are as follows. Um, TG, take note, corresponds to GD, and then PG corresponds to PD. And so we will have the equation TG divided by GD equals PG divided by PD. Okay. Now, before we substitute some of the values, we can actually find one more value for a certain part of this triangle. Okay? Triangle GPD. Take note, PG is 4, GD is 5, and so if we use the Pythagorean theorem, then PD must be 3. Okay? Or if you can easily recognize, this is actually a Pythagorean triple. So, seeing that one side is 4, the hypotenuse is 5, automatically the other side must be 3. Okay? So, if you know some of the Pythagorean triples. Okay, let's substitute the values in this equation. So, TG is what we want. That's the unknown side. So, TG divided by GD. GD is 5. PG is 4. And PD is 3. Now, solving for TG, we obtain TG equals 20 over 3. Now, let us replace TG in this equation with 20 over 3 to find BF. So, BF equals 8 plus 40 divided by 20 over 3. Now, BF equals 8 plus 6. So, BF must be equal to 14 units. So, our final answer is 14 units, and that is letter D.